have been on, but I got.
Oh,
off
I'll
and
just
it's
do it
like-
tonight at like 8 o'clock, and then it's like 10 o'clock, and you're like, oh, nice.
That's pretty much how homework for me every night is. It's like 9:30 on
So like me and Landon.
9:30 comes around.
Watch up here. On this first one, I lied. This isn't going to be a quiz. If we know this side's 7, this side's 7, what kind of triangle is that? We talked about it last time. It's a right triangle. Not only is it right, though, there's a special name for it.
Right,
Say it.
isosceles. I don't know what it was.
All right, right isosceles triangle. We're going to actually learn a different name for it today I'll use more than right isosceles, but if you see right isosceles or isosceles right in the book, it means the same thing. So just two different ways to name the same triangle. If this is a right triangle and these two are congruent, the two legs are congruent, what can you tell me about those two angles? They're congruent. Give me a number. 45. How'd you get 45?
Because the other.
All right, so three angles of a triangle should add up to be 180. And this one's 90. Well, the other two got to add up to be the other 90. Split that in half because those two sides are the same. Remember when we dealt with isosceles triangles, if the legs are congruent, then the angles across from them have to be congruent. Any guesses as to what math people call this triangle?
Trifecta.
A isosceles.
You guys have not good guesses today. I guess it's because it's Monday.
Trifecta.
45, 45, 90 triangles. All right? If we were to use Pythagorean's theorem on this, 7 squared plus 7 squared should equal c squared. What is 7 squared? All right, so Peyton's already jumped way ahead of us. You got 49 plus 49 equals c squared. That's 98 equals c squared. Take square root. These cancel. If they want a decimal answer, which I didn't specify here what I wanted, if they want a decimal answer, grab your calculator, take the square root. All right? If they want an exact answer, then you got to figure out,
What if it's not like
then do whichever you want. I won't, if it doesn't specify which one you want, I won't mark it wrong either way, unless, like with what we learned today, if you give me the decimal answer on this one, I'll mark it wrong. Because after what we learned today, you should know that there's an easier way to do it, and you should come up with the exact answer using that easier way. No, we're not quite that far yet. So on this, what's a perfect square number that'll go into 98? Look right back here and it should help you. 49. 49 times what?
2.
What is the square root of 49?
7.
So 7 comes out of the radical. 2 stays under the radical. 7 radical 2, that's your answer. I think we talked about these a little bit last time. And this is part of what we're going to cover today. If you have a 45, 45, 90 triangle, and I tell you this side here is 9, what's this side over here?
9.
What's this side?
See?
Look at your pattern here.
Oh, same thing. 9 radical.
All right? Give you another one. This is a 45, 45, 90 triangle. And normally they're not going to tell you both these angles are 45. If they tell you one of them's 45, what should you know about the other one? It's got to be 45 if that's 90. They give you that, and maybe they tell you this side over here is 5. What's this side over here got to be?
5 radical.
5 radical 2. What's this side down here?
5.
All right. Every single 45, 45, 90 triangle, that's the way it's going to work out. So if you pick up on that pattern, do we have to go through all this work we did with Pythagorean's theorem? No. It's too much work. Now, does that mean that every triangle is going to be a 45, 45, 90 triangle? No, there's billions and billions and billions of other triangles that aren't 45, 45, 90s. All right, these are the answers to page 346. Look through the answers, check your paper, be ready to ask questions here in a second. They give us the numbers 24 and 25. Three key things that we learned this first section last chapter. Three different proportions. If you remember those three different proportions, or you have them written down in your notes so you can refer back to them, be real helpful. The first proportion was dealing with geometric mean. Where's the 24 go in this proportion? What goes down here? What goes here?
Okay.
Remember, that's your geometric mean, those two x's, right? And then what goes down here? Cross multiply, x times x is x squared. 24, I know 4 will go in 24 6 times. 6, so that means you got $6 if you got quarters, so 600. 600 a perfect square number. Don't forget to refer back to your perfect square list. I think I added a couple since maybe you guys were in here. Could you keep that list going on forever? Yeah, I'm not going to. It's a pain in the butt. It just keeps going and going. But use that list every now and then. What will 600 break into? What's a perfect square number that'll go into 600? 100. 100 times what?
6.
What is the square root of 100? 10 comes out of the radical. What stays under the radical? 6. 10 radical 6. What was that as a decimal answer to help everybody out? 24 point something? Is that, what'd you get?
24.494.
So about 24.5.
Yeah, number 18.
18.
Remember how to do geometric
Problem 18.
For this one, could we look at the fraction?
Maybe. I haven't looked at it yet. Yeah, sort of. I'll show you. Problem 18, dealing with the radicals. It sort of works out if you know what you're doing with the radicals. Let's see here. We know x is going to go here, x is going to go here because we're trying to find the geometric mean, right? You got 8 radical 3 over 5. And on bottom you got 6 radical 3 over 5. When you cross multiply, get x squared. When you multiply these other two, and I'm going to come up here and write this, 8 radical 3 over 5 times 6 radical 3 over 5. Don't make these harder than they are. When you're doing math, it's common sense stuff. What do you think you multiply that 8 times? The 6, because it's in the same location, right? What do you think you multiply the radical 3 times? The other radical 3. And what do you think you multiply the 5 times? So what is 8 times 6? What's radical 3 times radical 3? Square root of 9. What's 5 times 5? 25. Watch, make sure you understand this. Square root of 9. Square root of 9 is what?
3.
So we could get rid of that. And that's like a 3 there now. Well, we're just going to multiply those two. 48 times 3 is what? 144. Now what do?
Reduce.
You could reduce maybe, but what did we do on the other problem before I erased it? If you're trying to get x squared by itself, you take the... Now watch what happens. take the square root of this side. And a lot of times math books do this. You guys are intelligent. You've been through math for several years now. Do they try to make answers come out all with stupid answers?
Yeah.
No, they don't. They try to make it come out something that seems sensible, something that's helping you out. Otherwise, I mean, if they did real world stuff all the time, then all your answers would never ever come out even, because in the real world, most things don't come out even. When you take the square root of a fraction, all you do, take the square root of the top, take the square root of the bottom. What's the square root of 144?
12.
What's the square root of 25?
5.
That's right. 12.
Okay, good, that's what I got.
Now, if you do that, I'm not sure, I think maybe if you have a TI-80 calculator and use your ABC button and take the square root using the ABC button, I think it might give you the answer as it'd probably give you a mixed number. Probably say like 2 2/5 or something, but same idea.
Where I am.
Problem 24. Sorry, my picture probably doesn't look quite right, but remember you got altitude drawn to the hypotenuse of a right triangle. 21, this is 7. 24, they wanted you to find the altitude, so I'm just going to put an X in there on the altitude. The other two key things to remember from last class, the two proportions. If you're dealing with an altitude, like on this problem, then you got to use this proportion. Altitude goes here, length of the altitude goes there. It's the geometric mean. Hypotenuse, part 1 on top, hypotenuse, part 2 on bottom. Somebody help me out. What was the other proportion? I don't remember. What goes on bottom here?
Oh, jeez.
Leg.
Leg. What goes up here? Leg. Hypotenuse part. And remember, it's the part that's hooked to the leg, right? That certain leg. Can't read that. What goes down here? The whole hypotenuse. So using those two proportions along with that geometric mean proportion, this time we're dealing with altitude, so we're probably going to be using this one. Sometimes you might be using both of them. You got to decide which one to use, which one you can actually solve something for. What am I going to put here if we're looking for the hypotenuse? Redraw it.
A giant line.
What do I put here? So X, what goes here? X. Hypotenuse part 1. What is hypotenuse part 1?
I don't know, where's that?
21. What goes here? 7. Now, somebody said 7 up here. Does it matter? No, for this one, doesn't matter which part goes where. All right? Remember, when you're talking about the hypotenuse, you're talking about the hypotenuse of the big triangle. Cross multiply. X times X is X squared. 7 times 21 is what?
147.
What is it? Now what? Take square root. Any perfect square number going to 147? When you're trying to figure this out, which of these numbers would you try to divide into 147? You go try to divide 4 in there? About 16. 36? No, probably not an even number, right? Because if you multiply an even number times something, it's going to come out even. All right? So the ones I would try, stuff like 9, 49, 81. How come I wouldn't try like 169? It's bigger than it anyway. It won't divide in it. So what is it?
That'd be something bragging right
49 will go into it. So it's square root of 49 times the square root of what? 3? What is the square root of 49? So 7 radical 3. The length of that altitude right there is 7 times the square root of 3. Again, find the measure of the altitude drawn to the hypotenuse. Did they specify to leave it in radical form?
No.
No. So if you got a decimal answer, was that going to work also? Yeah. Whatever 7 radical 3 is. 7 radical 3 is probably
Yeah, I got that.
9 or 10 or something.
It's 12.12.
Is it that far? 12? I guess that would be right. I don't know why I was thinking 9 or 10. That's so crazy. Other questions? 28? Problem 28. These are the harder ones, and these are the ones that are going to be on your test when we actually take a test over this. That'll be all right. If you know you're going to fail it, why don't you just leave it blank for me, and that'll make it easy for me to grade.
I'll get a few right, so it's not a 0.
So you get like a 20.
16% on this test.
Actually, sometimes I think 0 would look better than like 16%. It at least looks like you didn't try. When the 16% makes you look like you tried, and it's terrible.
That might be true. I don't know, take it home, show it to your mom and see if...
Neither one.
Who cares? I mean, I don't think a 16 would affect your grade that much anyways compared to a 0. Still
What just
better.
happened?
Oh dear Lord. Back to the drawing board. Brighton, be quiet.
No, no.
Good.
Round 2.
You worked hard on that triangle.
On the little John
Did you, Mr. Oversaw?
Right.
Yeah.
Yeah, you worked hard.
I'm a genius.
Are you playing Skyrim?
No, I don't have Skyrim.
Next gen graphics? On the calculator?
I like that. I pull out.
What
one.
is happening?
It's like a little
Emma,
mini calculator.
stop.
and
Alright,
it's
so
the
the quiz
controller.
is over triangles, guys.
Move forward 1 unit. 1 equals 1.
All right, watch up here. Again, this time we're actually looking for a leg. We could be dealing with the altitude. We don't know the whole hypotenuse. So you just got to pick. And this is what makes dealing with these a little harder. You got to decide, am I using Pythagorean's theorem? Am I using the leg proportion? Am I using the altitude proportion? And make a decision. Which variable you want to try to find first?
Why?
Y? Well, if we're looking for Y,
Why?
then we got to set up which proportion? Leg or altitude?
Leg.
Leg. Where's that Y go at?
The bottom
Bottom,
top right.
top? What's the part of the hypotenuse that's hooked to that? 6. So far, so good. What's the whole hypotenuse?
6 plus 6.
What's the whole hypotenuse?
There's 2.
Can we solve that?
Oh, jeez.
It's got 2 variables in it. So instead of using that one, you say, hey, the leg one didn't work, so probably we're going to go to what? The altitude one and try that. Don't just give up, all right? Just know, hey, I'm going to use that here in a minute once I figure out what X is, and I can come back, plug in, and it'll make it easier because I already have it. What goes here? 8. What goes here?
8.
Hypotenuse part? 6.
Part 1.
Now, part 2, do we know what part 2 is?
No.
2 different ways you could do this. You could make part 2 something completely different, like A or whatever. Find A, then stick it in there and add the 2 together to find X, if that's easier for you. Or, if this whole thing is X, how long is this part from here to there?
X minus 6.
X minus 6. So you could stick that in there if you wanted. That's the way I'm going to do it, because it's not that difficult. Put parentheses around that. Cross multiply. What do you get there? 6x minus 36, good. Cross multiply there. 64. Add 36. These cancel. 6x equals 100. Divide by 6. What's x equal? Don't give me a decimal answer on this one because it's a silly answer. So you use the fraction button.
On sheet.
Oh, that's ridiculous.
What is it? 16 and 2/3? If that's 16 and 2/3, the whole hypotenuse, how long is this part from here to there? 10 and 2/3? You just subtract 16 2/3 minus 6, right? 10 and 2/3. We didn't really need to know that, but just in case. What do I stick in place of x right here now? 16 and 2/3. Now, I'm actually, did I forget a z or something on this one?
Z.
Is it down here? I'm going to stick 16 and 2/3 in here, but what I'm going to do, I'm going to change it. 16 times 3 is what? 48 plus 2.
50.
So I'm going to put it 50 over 3, just to make it easier when we cross
I
multiply.
don't understand how you got 50 for 3.
You multiply the whole number times the bottom, and then add the top. So if we got 16 whole pies and 2/3 of a pie, if we want it all in thirds, we would have 50 thirds of the pies. Does that make any sense? So if I was to actually, I'm not going to draw all the pies out here. Maybe. So you got 50 of those little sections. We cross multiply, you get y squared. 60 times that. Here, this will cancel. If you put a 1 underneath there, if it helps you. 3 will go into 3 once, 3 will go into 6 twice. Multiply straight across, you end up with y squared equals what's 2 times 50? 100. Comes out awful nice now because what's the square root of 100? 10. So this side over here is 10. Couple different ways you could find z. Could we go back and do the leg again and put z in there? Yeah. The other thing you could do, you could use Pythagorean theorem because you know this side's 10, you know this side's 16 and 2/3, and you wanted to find z, so you could just use Pythagorean theorem to find that third side. If that's easier because you've been doing it longer. If you wanted to set up the proportion would look, if we're finding z, that's a leg, so z goes here, z goes there. Part hooked to z is 10 and 2/3. The whole hypotenuse is 16 and 2/3. Probably don't want to do it this way because all the fractions. Z squared. If you take your calculator though, somebody help me out with their calculator. You got all these calculators that do the fractions for you. Hit 10, ABC button, 2, ABC button, 3, times 16, ABC button, 2, ABC button, 3, equals or enter. It'll do it all for you. It just takes a second.
I don't even know how to do that. The calculator is smarter than I
You
am.
gotta use parentheses on that one, then hit the math button.
No,
So-
you don't.
So give me here, Brian, I'll show you.
Okay. I was trying to figure it out, looking at the manuals and stuff, and it wasn't helping.
If you have a big calculator like this and you've been carrying around the little calculator because it does the fractions, but if you have this, it'll do it also. All you do is you hit parentheses. Well,
No, it won't work. Ha ha.
the bad thing about this one is you really can't put it in this way, so you got to change both of these into improper fractions. What's 10 times 3? So you got 32 over 3. Here we already changed this one. It was 50 over 3, right? So if we do it this way, Brian, parenthesis, 32 divided by 3, close the parenthesis, times, parenthesis, 50 divided by 3, close the parenthesis. Then you hit the math button, and right at the top of the math button it says fraction, hit enter. and it comes out looking like this, then all you gotta do is hit enter and it'll give you the answer.
I think Brian's knowing one.
1600 over 9.
1600 over 9. Now watch. Is that what everybody else came up with? The little ones probably gave you some mixed number, right? Then you got to remember that mixed number and do what to it, because we're not quite finished. Take the square root of both sides. Well, with Brian's calculator, we do this. That's going to get rid of, what's the square root of 1600?
40.
40. What's the square root of 9? 3. Z equals 40 over 3.
That was so complicated for just.
It's not complicated. Could you change that into a mixed number? How many 3's are there in 40? How many 3's in 4 there?
13.
13. With how many left over? 1/3. 13 1/3. Same answer as that. All right. This is the other page, page 3, what was it, 54 or something? Check your answers on 354, see if you have questions. This page. Everybody understands Pythagorean's theorem?
About 36.
36. Problem 36. Let's see. Denver is located about 105 degrees longitude and 40 degrees latitude. San Francisco, 122 degrees longitude, 38 degrees latitude. Las Vegas is located about 115 degrees longitude, 36 degrees latitude. Using the lines of longitude and latitude, find each degree distance. San Francisco to Denver. Too confusing. We got San Francisco there, Denver over here, and we have Las Vegas down here. Looks something like that. It's sort of hard to tell with this, but guess what kind of angle that right there is?
A right angle.
That's a right angle. San Francisco to Denver. San Francisco. So we want this one up here. That's going to be our X. Trying to think. How did we do this one? Let's see. I don't even feel like going through all this again. 105 degrees longitude, 40 degrees latitude. That was San Francisco, right? No, that's Denver, of course. San Francisco's 122.38. And Las Vegas 115.36. Could we use coordinates on this and just find the length of that?
Yeah.
Yeah. If we take, just remembering back the distance formula,
Triangulate.
that's what you do when you triangulate, is use the distance formula. So when you hear boats and stuff talking about triangulating to, you got the North Star and you got whatever Polaris or whatever another star is, you triangulate between those. That's what they're doing. Not the West Star, not the East Star either. But that's what they're doing here. What's 122 minus 105? Nobody knows? About 17. 17 squared plus, what's 38 minus 40? And it's actually a -2. Does it really matter if it's negative though?
No.
Squared? All right, how come that's not gonna give us the right answer?
You sure it's 17?
Yeah, I might. What's 17 squared? Yes, I'm positive it's 17. No, I know how to subtract. I'm getting ready to throw something at you.
I have a brick.
289 plus 4.
Yes.
What?
Yeah.
289 is what? 200 and plus 4 is 293. What's the square root of 293?
17.11724277.
So I rounded my answer off.
I was using that yes calculator. Very good. I typed in that and I was like, and that
So-
equals?
This is the degree distance between them. Does that really tell you a whole lot if you're not a pilot, knowing that San Fran is 17.1 degrees distance away from Denver? That doesn't really help you, right? If you're a pilot, and probably even a lot of pilots don't have a clue what that means, because what do?
They
Fly.
They just fly. They look at their gauges, and their gauges tell them, and they say, oh yeah, this gauge is supposed to be at this gauge is supposed to be at this, and they probably don't.
17 minutes.
A lot of them don't have a clue really what they exactly mean. It'd be nice if you had a pilot that knew exactly what each thing meant, right? So, but that doesn't always work out.
I don't think in the olden days they did that.
Because if something does go wrong,
ETA.
they're out of luck.
Always blame the co-pilot.
Huh?
Always blame the co-pilot.
Yeah, that's.
That's
Well,
why
usually in the airplane, it doesn't matter who you blame. Once you crash it, it ain't gonna matter whose fault it was.
somebody's gonna be to blame from Malaysia.
According to
Is it gonna matter?
when Denzel Washington
Not if they're all dead.
No, they're on Gilligan's Island
So that
somewhere.
they're all stranded somewhere. That's part of your assignment, is to get on Moodle and do that quiz. Today is the 24th. Go ahead and start copying this down. We're going to be dealing with special right triangles. Now, these special right triangles, Brian talked about sine, cosine, and tangent a few minutes ago. We're going to get into that next time. This sort of goes along with that. But if you can recognize these special pairs, just like if you remember the families from last time, it makes it a little bit easier. Each section, the rest of it, this will be a bonus worksheet. All right? So this will be bonus. If you want to get some bonus points, turn this in next time, and it'll count as bonus. So,
Wait, is this the homework too?
no. This is just an extra bonus worksheet. So on the top of 7-1, pick me one problem out of those 6, and I'll do one problem out of the top ones there.
No.
5.
5.
Dang, I was gonna say 2.
Problem 5. Watch, because I'm going to go extremely quick. If we're doing geometric mean, I know x goes here, x goes here. The numbers they give us this time, 2 radical 2. That's the first number. 5 radical 2, that goes down there. We cross multiply. X squared equals, when I cross multiply this way, 2 times 5 is 10. Square root of 2 times square root of 2 is the square root of?
4.
What is the square root of 4?
2.
What's 2 times 10?
20.
Now what? Take square root of both sides. Is 20 a perfect square number?
No.
But what will go into 20? Give me a perfect square number that'll divide it evenly into 4. 4 times 5, right? What is square root of 4? 2 radical 5 is your answer. Pick me one from 7 through 10.
10.
Problem 7.
Oh.
Oh, that's why
Nope.
On problem 7, if we're looking for the altitude, it says, oh, I'm sorry, I messed up over here. Back over here. What did the directions say to do?
Find the
And.
compare the exact
Oh,
answer.
we have to do the
This is
difference.
the exact answer. What else did they want?
The nearest 10.
Nearest 10th also. So somebody help me out. What's 2 times the square root of 5 rounded off to the nearest 10th?
2 square root of 5 equals 4.5.
Okay.
So exact answer, rounded off answer. On these, I'm not gonna throw a big fit. They want both answers. I just give one of them. We're looking for the altitude this time. So I'm gonna put an X in there. Well, if we're looking for the altitude, which of those 2 proportions are we gonna use? The altitude one or the leg one? Probably the altitude one. What goes here?
X.
X. What goes here? X. Up here is hypotenuse part 1. So 2. What goes here? Cross multiply. You end up with x squared equals 14. Take square root of both sides. Is 14 a perfect square number? Is there any perfect square numbers that will divide evenly into 14? 1 will, but that doesn't help us well, does it? Square root of 14. That's the way I did my answer. If it won't divide out, won't simplify down, you can just leave it that way. You don't have to do anything else to it. Pick a variable.
X.
X. X is the what in this?
Altitude.
So we're probably going to be using the altitude theorem again. So where's X go?
Bottom,
Bottom,
upper right.
top. What goes here?
4.
4.
10.
Yes.
What goes here? 4.
Nick,
Cross multiply. X squared equals what? Square root of both sides. 40 a perfect square number.
that would be a negative 2 square.
What will go into 40? Square root of 4 times 10, right?
Yes.
What is the square root of 4? 2 radical 10. Be your answer. This one, they didn't even tell you what to
We didn't find Y also.
decimal or anything, so I'd leave it that way. Y. Y is a what in this?
A leg.
Leg. So we got to use the other proportion. What's going to go here?
Y.
Y. How about here?
Y.
Remember, it's part hooked to that leg, so what is it this time?
4.
4. And the whole hypotenuse?
Oh man.
Y squared. What's 4 times 14?
56.
Square root. Is there a perfect square number that will divide into 56 evenly?
That'd be a negative ghost right.
Sure.
Yeah.
I know 4 will because I just multiplied 4 times 14. You guys told me it was 56. So I know at least that will.
Okay, so
Anything other than 4? Just 4, so 4 times 14. What is square root of 4?
2. 2 radical 14.
2 radical 14.
Slash McGraw-Hill.
So 5, 12, 13, these all fit in the family. Give me another one that fits in the 5, 12, 13 family.
15 or 10.
15 I heard.
Oh, dang it. 36.
36.
39.
39. Those all fit in that. If you can pick up on those triples, makes everything a little easier. Pick me one down at the bottom, 13 through 18.
16.
16. Problem 16, watch carefully. If you're trying to determine whether that could be a right triangle or not, all you're going to do is use Pythagorean's theorem. A squared plus b squared equals c squared. How do you know which one c has to be? The longest, the biggest. So which one is it in 16? 6/5, right?
Yes.
Square that. What's a?
2 over, well, it doesn't really.
2 fifths squared, what's B? 4 fifths. And Brighton's right, it doesn't make any difference which one of those you put in which spot. Don't make this harder than it is. All you're going to do, square each number. What's 2 squared? 4, what's 5 squared? So 4 over 25. What's 4 squared? 16 over 25. On the other side, what's 6 squared? 36 over 25. Add these two, they're like terms. So we can just add them. What's 4 plus 16? 20 over 25. Notice I'm not even reducing any of this or anything yet because
That's a no.
it doesn't make sense to do it. Are those the same?
No.
So is this a right triangle? Not right triangle.
I'm putting
Using properties of a 45-45-90 triangle and a 30-60-90 triangle. A 45-45-90 triangle is also called an isosceles right triangle. You can write that down on the next slide here if you want. So 45-45-90, you might write isosceles right underneath that, or right isosceles, it doesn't matter which way. As long as you know a 45-45-90 triangle has a right angle in it, and the two legs are congruent to each other. In any of these triangles, they're probably not going to tell you all 3 angles. They're going to tell you that you have a right angle, then they might tell you that this one here is 45 degrees. How come they wouldn't tell you the other angle? They want you to figure it out. And if this is 90, that's 45. What's the other one got to be? 45. 3 angles of a triangle have to add up to be 180. When you see this in the book, when you write the theorems and postulates down in the book, they probably got this labeled a different way than I have. They probably got, instead of L, they got X's. So they got X, X, and X radical 2. Doesn't matter. It's just a different variable. I don't use X to label it because the way I teach this, if you use X and you already got an X in there, guess what happens? You got double the same thing and everybody gets confused. Alright? So that's why I use L's. And you probably won't ever see me write this L. That's a capital L. What you should probably use, and what I'll use most of the time, is a cursive L, a lowercase cursive L. It's just the way I learned it. I just don't know how to do that on the computer, so that's why I put a capital L there. Yeah.
You have to change the font.
Yeah, you just get the font change.
Yeah, see, but changing the font when you're trying to do shapes and stuff in it doesn't work out the same. You might be able to do that on
Paint.
a Word document, but in Paint and stuff like that, the font's not quite the same.
I don't know how you do the radicals.
Right, so on this, anytime, yeah, some other things aren't in there. Anytime you have a 45-45-90 triangle, the first thing you're going to do with it, and I always do this, I go in here, this side across from the 45-degree angle, I label it L. The side across from the other 45-degree angle, I label it L. Side across from the right angle, L radical 2. That's the first thing. They're going to tell you some numbers in there, but you go through and you write each one of those in every single time. That's going to make everything a whole lot easier. We already did a few of these there at the start of class. If I told you this side was 3 and this side was 3, what's this side over here?
3 radical.
3 radical 2. Some of them you can just pick up on and just write down the answers. Other ones going to be a little more difficult. All right, draw these 2 triangles. and I'm not gonna throw a big fit unless you're getting confused on the harder ones, something like these two. If you didn't label them all, then go through and draw in the arrows and do all that stuff, probably wouldn't be too upset because it's pretty easy. But if you're getting confused on the harder ones, then you need to make sure you're doing that every time. Is this an isosceles right triangle? So what do you know about this angle right here? It's got to be 45 degrees. Sides across from the 45-degree angle should be labeled L, L, side across from the right angle, L radical 2. Well, usually what I do is I circle the part where I actually know a number, and that's where I set up my equation. So L equals what this time? 3. Is there anything to solve on that equation? No, you just know L equals 3. So I can take that 3 and write over here. How long's the hypotenuse? 3 radical 2. How long's the hypotenuse in this one? All right, write that down. This is a little tougher. This is one Nick's going to make sure that he's got down there because this is the one that's hard. This is the one that I'm going to start giving people detentions for. You can tell Mr. Wendell that you can't serve his detention because you got one for asking a silly question during Mr. Eversole's class about his class.
Maybe I was asking about Mr. Bloom's class.
Do you really want to keep talking?
That's probably not a good idea.
We got this 45, 45, 90 triangle. And they tell us that the hypotenuse, that's the side across from the right angle, is 10. Sides across from the 45-degree angle should be labeled L and L. Side across from the right angle, L radical 2. So this one is easy?
Yeah.
It is?
No. Yeah.
What's L this? What? And this is where you're going to have trouble. Can I just say L is 10? No. You got to do this equation right here. The equation, you take whatever part you knew and you set what you labeled it with equal to each other. So L radical 2 equals 10. How do you solve for L?
Take the square root.
What would you do if it said something like this? L times 3 equals 30. Divide by 3. Guess what you're going to do here? Divide by radical 2. When you divide by radical 2, those two cancel out. You're left with L equals 10 over radical 2. What did we say last time about having radicals in the denominator? You can't have it. All right? So what you got to do, and if you watch this, if you do this pattern over and over again, I'm going to come up here so I can actually have space and don't have to bend over. I'm just rewriting that. It's going to be the same pattern over and over again. So after a while, you can see the pattern and it'll just be real easy. On top, 10 times the square root of 2 is just 10 radical 2. On bottom, what's square root of 2 times square root of 2?
Square root of 4.
Square root of 4, which is what?
2.
2. So that 2 just sort of, when you multiply that, it just comes out of the radical on the bottom. Now here's another thing you got to watch out for. 10 and 2, guess what you can do there? Reduce. What will go into both 2 and 10? 2 will go into 2 once, 2 will go into 10 5 times. So what's L equal? 5. 5 radical 2. Do we need the 1 on the bottom? How long is that leg right there then?
5 radical.
How long is that leg?
5 radical.
5 radical 2. So you're just doing that pattern over and over again. If they tell you one of the legs on a 45, 45, 90 triangle, it's easy. If they tell you the hypotenuse, not as easy. Now, the hypotenuse could be easy if they gave you something like this. They told you this was a 45-degree angle, and they told you this side over here was 7 radical 2. How long is this leg? 7. How long is this leg? 7. So if they gave you a radical 2 part over there, that's great. If they give you a whole number on that hypotenuse without the radical, then it makes it a little more difficult. You got to do a little extra work. All right, 30, 60, 90 triangle. These 3 parts right here are probably the 3 most important things on this slide. Again, they're probably not going to tell you all 3 angles. Probably tell you 2 of them. Expect that you're going to find the 3rd. I'll give you a second. This part and this part say the same things, just in 2 different ways. What's the difference besides being 45, 45, 90, and 30, 60, 90? What's different about this one? What do
It's
you
not
see?
isosceles.
It's not isosceles, okay. What else? That's the same. What radical did you have on the other one? 2. What radical do you have on this one? 3. You got to make sure you keep those 2 separate. The way I remember it, 45, 45, 90 has 2 sides congruent. It's got the radical 2. 30, 60, 90. We'll go into all 3 of those, 30, 60, and 90. 3. So I remember that it's radical 3. If that helps you, then do it that way. Whatever, however you remember how to do it, doesn't matter. Whatever's easiest for you. And our theorems that we had earlier. Which side has to be the shortest side in a 30, 60, 90 triangle? The one across from the what? The 30-degree angles. Which one has to be the longest? The hypotenuse across from the right angle. And that sort of goes into this. When you go to label these, this one's going to be a little more important than the other one. Side across from the 30-degree angle every single time. And again, the book I think uses X's instead of L's. I use L's. Side across from the 30-degree angle, label it L. Side across from the 60-degree angle, L times the square root of 3. Side across from the right angle, 2 times L, or 2L. Every single time you see a 30, 60, 90 triangle, go through and label the 3 sides that way. Make that make any sense? Does that seem difficult? Is Corbin going to catch up to you now?
Yes.
Problem Corbin's got now is that 2 people in the other class scored like 105 on that last test, so they might be flying by all of you.
My mom was mad at me that I was mad about that. And then you punched her. Bam. Ready to kiss her.
That's your mom?
Yep.
Right. That's why you're the way you are.
Punched her, kiss her.
Brian, I'm worried about your household at home.
Right. When you get ready to do that, please give me a call so I can come watch.
Skype me.
All right.
Smack me. I want to see what your mom would shake you at.
All right.
My mom would like touch your fist.
Write these 2. Draw these 2 triangles. Write this stuff down. 2 examples here. We're going to do these 2 examples real quick. Notice again, I didn't give you all three angles, but if this angle's 90, this angle's 30, what's this other one gotta be? It's gotta be 60. So, you should be able to figure that out. In this first one, go through and label all the sides. Side across from the 30-degree angle should be labeled L. Side across from the 60-degree angle, L radical 3. And this is why I don't use X, because if I stuck an X in there and I said this is X and this is X radical 3, is that going to be confusing?
Yes.
Yeah. Side across from the right angle, 2 times L. Which one of those three did I know? The L, 2L, or L radical 3?
L.
So this part right here, that's where I set up my equation. I just take what I wrote down, what they had down, set them equal to each other. So L equals 3. How do I solve that? It's already solved. That's a nice one, right? It's already solved, so all you got to do is everywhere you see L, you're going to replace it with what? 3. So what's X over here? 3 radical 3. 3 radical 3. What's Y over here? 6. 2 times 3 is 6. Little tougher one. This is the harder one. Side across from the 30-degree angle should be labeled what?
L.
L. Side across from the 60-degree angle?
L radical 3.
L radical 3. Side across from the right angle?
2L.
2L. Which one do I know this time? That one there, right? So what equation can I set up?
L radical 3.
L radical 3 equals 6. Very good. So divide both sides by the square root of 3. These cancel. You're left with L. That's the whole purpose. Problem is, can you leave that radical in the denominator?
No.
So you multiply top and bottom by the square root of 3. On top you get 6 radical 3 over radical 9, which is just 3, right? What can you do with the 3 and the 6 here? 3 will go into 3 once. 3 will go into 6 twice. So what's L equal? 2 radical 3. How long is this side then? 2 radical 3. Don't get confused. You say, well, that was just supposed to be L though. Well, L is that whole thing. How about this side over here? If you double that, what do you get? 4, be careful. 4 radical 3. Just take it times 2. He meant, I know what he meant, and that's what a lot of people do. They double the radical also. Don't. If I told you to double 2x, if you got 2 x's and I got 2 x's and we put them together, how many x's are we going to have? 4 x's, not 4x squared, just 4 x's, right? So make sure when you stick it in there you don't do what you were thinking there when you doubled the radical also.
What about the
All right, the assignment's on page 360. Don't forget about that quiz. It's on Moodle under today's date. It says quiz, I can't remember exactly what it says, but it says something like quiz 7-1 and 7-2. Something along those lines. So make sure you get on there and do that. Please don't forget to do that quiz. It closes down Friday. I put a whole lot of zeros in there at the end of the last 9 weeks. People that didn't go back and do those OGT quizzes and stuff. And then I had people come in like last Friday saying, hey, can you open up that quiz for me so I can do it?
I didn't.
It was open for like 3 weeks. I kept opening it.
Maybe one more day.
Another day, and then you're going to ask me on the last day of the